Welcome. Today I'm going to take you through building your first distributed data structures using Hazelcast. So first place to visit is HazelcastStart, and from here we're going to pick up the download. So if you click up here on downloads, you can see here that we have a bunch of different files. I'm going to use Hazelcast 3.1.zip. So it's a zip file. You can actually get Hazelcast as well from Maven Central. You can also get it from GitHub. So, this is Apache licensed open source software, so you can just grab it. The only thing that we depend on is the Java JDK, so be sure that you have that installed and executable on your command line. So let's have a look-see on the desktop what arrives. So this is a zip file. I'm just going to unzip it here onto the desktop and let's look inside. So this is the Management Center WAR file. You can use it to activate a web-based management console. We're going to do that in a different video. Today what I'd just like to do is go quickly through this. Here's the Apache license, looking inside. So Hazelcast 3.1.jar is really all you need to create your first cluster. 2.6 meg jar file, so pretty easy, pretty small. These other things are inside of this thing called Hazelcast All, which includes the Hibernate library, Spring, and some of these other libraries. Here's the docs file. You can read it in PDF or HTML as you wish, but we're going to spend most of our time here in the bin directory. So there's something here called run.sh, which really just invokes that jar file that I mentioned earlier. So I'm running my first instance here of Hazelcast. So this node has booted up. You can see that there's one member in this cluster, and that this member has identified itself as running on this IP address on this port. So not that interesting until you have two nodes running. So I'm just going to boot up my second node. What you're going to notice is as you get two or more nodes running, you're going to notice that these nodes auto-discover the cluster, and they're going to join to pool resources such as memory and CPU. This is the test app that I mentioned before, so we can actually execute some commands against this test app. So the test app has actually done something very handy, which is built a few data structures for us by default. Quickest way to get your way around this test app is just to type help. Help actually gives you a bunch of commands that you can play with. What you're going to notice right away is you're going to notice that there are a few data structures that have already been built. So there's a queue called the letter Q. There's a set called S. There's a map called M, and there's some locking commands that you can execute. In addition to these, there's a list called L, and atomic long called A, and then there's executor service. So there's a bunch of different built-in functions to this test app that are ways of exercising the core of Hazelcast. But today, I just wanted to play with the basic map. So, this map is called M. So we're just going to put key value pairs in here. So I'm going to put headquarters of Hazelcast. Put that into here. And what you can see immediately is you can get that value out of the second JVM. So this is really showing you that the map is fully distributed data, and a bunch of different JVMs can access exactly the same data. So I put the key value into one JVM, pulled it out of another JVM. And obviously we can do the same thing in reverse. So you can put a value into key number 2. Let's put London in there. And then obviously you can get that out. Let's use the entries command, and that will give you the data. So as you can see, there's two entities in this map. So let's have some more fun and boot up a third instance here. And why don't we just make a fourth one just for fun here. And then what we can do is we can put a few more values in here. Let's put Antwerp in here. And why don't we put in this fourth one, Munich. So as you can see from m.size, you can see that there are 4 entities here, and we're going to come up here to do m.entries, So what's pretty clear from this demonstration is that you have one data that's shared among 4 different JVMs thanks to the clustering capability of HazelCast. So I just want to do one last thing before signing off, which is show you a little bit about mutex or distributed locking in HazelCast. So what we can do, for example, is we can lock a key. So we can put a lock on number 1. Down here we can put a lock on number 2. So to remind you again, 1 and 2 are Palo Alto and London. So if you wanted to, you could try to replace the first value Palo Alto, m.put 1, and you could put a new city like Tokyo in here. So as you can see, it's blocking. There are a variety of different locks that you can use. So you can use temporary locks for a certain amount of time, or you can use tri-lock, or you can use object level locking. So there's a lot of locks available. I just wanted to demonstrate very simple ones. So let's try to replace the second value here. And we'll put Beijing into here. So again, this is locking on the second lock. So for example, this is the lock holder for lock number 1. So for example, if you said m.unlock 2, you would get an exception. And that exception makes a lot of sense since this is not the lock owner, you can't unlock that. So why don't we try unlocking from here? m.unlock 2. So now, if we do m.entries, you'll see that in fact number 2 has been replaced and it's now Beijing. However, entry number 1 is still blocking on Tokyo. So what happens if the lock owner dies? So let's just go ahead and kill off this node here. And what you'll see is again that single point of failure, you'll see all the data has integrity. So we're going to put m.entries into here. So as you can see, there are still 4 entries, but since the lock owner died, the m.put into key 1 committed. So now you have Tokyo and Beijing in your map. As you can see, there's a lot of functionality in here. I'm just scratching the surface. Again, if you type help into the test app, you can see that there are lists, there are queues, there are sets, and there's a variety of other little functions that you can apply. One thing that's kind of interesting as well is the distributed execution service that allows you to take all the processors that are running in your cluster and execute processes on them. So, I'd like to get into those in a separate video. So for today, congratulations on setting up your first distributed data structure using HazelCast.